Solid-liquid mixtures. There are two categories of solid-liquid mixtures. In one category, the solid dissolves in the liquid and is said to be soluble. In the other category, the solid does not dissolve and is said to be insoluble, resulting to an insoluble solid-liquid mixture. Experiments. Testing the solubility of different substances in water and propanone. Let us observe these experiments to understand the solubility of different substances in water and propanone. Propanone, also known as acetone, is a colorless, flammable, and volatile liquid that is used as a solvent for many substances. In the experiments, the following substances are added to water and propanone, and the observations noted in each case. Sodium chloride, sugar, sand, sulfur, oxalic acid crystals, potassium nitrate, iodine, naphthalene. It is observed that sodium chloride, sugar, oxalic acid crystals, and potassium nitrate dissolve in water. Sugar, oxalic acid crystals, naphthalene dissolve in propanone. Sand, sulfur, naphthalene did not dissolve in water. Sodium chloride, sand, sulfur, potassium nitrate did not dissolve in propanone. Sand and sulfur did not dissolve in both water and propanone. Substances that dissolve in a liquid are said to be soluble, while substances that do not dissolve are insoluble. When a substance dissolves in a liquid, the substance is called a solute and the liquid is called a solvent. The resulting mixture is called a solution. When the solution is stirred, it forms a homogeneous mixture. Separation of insoluble solid-liquid mixtures. Experiment: separating sand from a sand-water mixture. Sand is insoluble in water. When a mixture of sand and water is allowed to stand, the sand settles at the bottom. The water can then be poured off carefully. This method of separation is called decantation. It is used in separating insoluble solids from liquids. However, it is not efficient because some solids still pass into the liquid in the process of decanting. That is why the water collected in the second beaker is not clear. It still contains small suspended particles. Sand and water can also be separated through filtering. A filter paper is folded into a cone shape and placed in a funnel. The mixture is poured carefully on the filter paper and the liquid is collected in a conical flask. Fine sand particles are trapped and collected in the filter paper. The solid particles that are left on the filter paper are called residue. Water collected in the conical flask is clear because the filter paper does not allow solid particles to pass through. The liquid collected in the conical flask is called a filtrate. This method of separation is called filtration. Filtration is used on large scale in water purification plants. Dirty water is allowed to pass through a filter bed made of layers of gravel and sand. Suspended particles are trapped by the gravel and sand while the water passes through. Domestic water filters use the same principle. Separation of soluble solid-liquid mixtures. As we have already learnt, some solids dissolve in water or other solvents to form a solution. There are various ways in which these soluble solid-liquid mixtures can be separated. To understand some of the ways this can be done, we shall observe a few experiments. Experiment. How sodium chloride can be obtained from a mixture of sodium chloride and water. Let's observe this experiment to understand how sodium chloride can be obtained from a mixture of sodium chloride and water. In this experiment, a sodium chloride solution is placed in an evaporating basin. The evaporating basin is heated until crystals start forming. The evaporating basin is then transferred onto a water bath and heating continues to dry the crystals. The crystals are then allowed to cool. Sodium chloride, common salt, is soluble in water and therefore cannot be separated by decantation or filtration. The evaporation basin is heated to drive away water into the atmosphere. This process is known as evaporation. When crystals start forming, the evaporated basin is transferred to a water bath so that the salt does not spit out of the basin as heating continues. This process is used to obtain salt from seawater. Experiment. How a mixture of sand and sodium chloride can be separated. Let's observe this experiment to understand how a mixture of sand and sodium chloride can be separated. In the experiment, a mixture of sand and sodium chloride is put in a beaker. Water is then added and warmed as it is stirred. The mixture is allowed to cool. The mixture is then filtered on filter paper and the filtrate is collected on an evaporating dish. The water is evaporated until crystals start forming. The solution is allowed to cool until crystals start forming. Sand is insoluble in water and is separated by filtration. It is collected as residue on the filter paper. Sodium chloride is soluble in water and is contained in the filtrate. Therefore, to recover the sodium chloride, evaporation is carried out. The hot concentrated filtrate is then cooled to allow more crystals of sodium chloride to form. Both filtration and evaporation methods were used in this experiment to separate the mixture. Experiment. How copper 2 sulfate crystals can be obtained from copper 2 sulfate solution. Let's observe this experiment to understand how copper 2 sulfate crystals can be obtained from a copper 2 sulfate solution. In this experiment, concentrated copper 2 sulfate solution is put into an evaporating basin as shown. Using a water bath, the solution is heated to evaporate excess water. As heating continues, a glass rod is dipped into the solution regularly and allowed to cool in the air. When crystals start forming on the glass rod, the evaporating basin is removed from the bath and allowed to cool. The glass rod is dipped into the solution to find out whether the solution can form crystals on cooling. When crystals form on the glass rod, this is an indication that the solution is ready to form crystals. At this point, the solution is said to be saturated. A saturated solution is one in which no more solute can dissolve at a given temperature. The process of obtaining crystals from a saturated solution is known as crystallization. This method can be used to separate most soluble substances from their solutions. Crystallization is used in several processes, e.g. extraction of salt from salty water, extraction of sugar from sugarcane, extraction of medicinal substances from plants. Experiment. How to obtain a solvent from a solution. Let's observe this experiment to understand how a solvent can be obtained from a solution. In this experiment, a sodium chloride solution is heated until all the solvent has evaporated. This can be achieved by placing sodium chloride solution in a boiling tube or a round-bottomed flask as shown in the setup. The solution is heated until all the solvent has evaporated. As heating is done, the steam passes through the delivery tube, where some condenses on the cooler parts of the tube to a colorless liquid. The steam is cooled and condenses to liquid water in tube B. The cold water in the beaker, therefore, acts like a coolant. A white solid remains in tube A. The white solid is sodium chloride. This method of separating a solute from a solvent is called simple distillation. The liquid collected in tube B is called a distillate. No residue remains if the distillate is placed on a watch glass and evaporated. This shows that the distillate no longer contains dissolved sodium chloride. When sodium chloride solution is placed on a watch glass and evaporated to dryness, a white residue is left behind. To improve the condensation process, a Liebig condenser is used as shown. Thank you for watching this chemistry lesson. Please subscribe to this channel and other Genius channels relevant to your level of study.